Hey guys, here at APEC for Teledyne LeCroy, Jason Lemke. I thought we'd show you something that we're really proud of at the show here. We just came out with this CP1000. It is a 1000 amp current probe that is rated at 1.5 megahertz. It is the fastest 1000 amp probe on the marketplace right now. So why is that important? We're here at the show. We're hearing a lot of discussion about how power levels are increasing for AI data centers, how EV is becoming more power hungry as well. And so you're going to need tools to be able to pull that information into something like an oscilloscope and then figure out what's going on with your system. So we've come out with this probe. It's going to give you very fast rise times because of that high bandwidth, and it's going to give you 1000 amp capability in a current probe. It basically picks up, and unlike CTs, you can open it up, slide the cable in, you don't have to unwire it, clamp it back down, lock it in, and now you are ready to start making some current measurements. So that's one part of it, and once we have a probe connected up, you still have to pull that signal into a scope. So if you'll walk with me over here, so once you have your current probe connected, you might want to bring it over to a fancy LeCroy oscilloscope. And the LeCroy oscilloscope, this one that we have here, has 8 channels, which means you can go ahead and hook, say, 3 high voltage differential probes in conjunction with your current probes and pull all of those signals into the same screen. So what we're showing here is basically a motor setup. We've got a 3-phase motor with a pulse width modulated signal coming in, and we're looking at our voltages and our currents. Now, lots of equipment can do that part of it, but one of the things that makes this type of equipment great for that kind of analysis is we now can start to look at some very dynamic measurements that are happening as we're ramping up the motor. So if we start to have a, say, soft start happening with the motor or something happening to the motor in real time, we'll be able to see any of the changes in our power that's happening. And that gives us a lot of control on debugging systems like this. So when you have something that's happening dynamically in your waveform, you'll be able to use the oscilloscope to really focus on what's going on at that particular point in time. After you've done that, if you want to do more characterization, there's of course a full set of measurements around everything that you would want to look at in a motor drive analyzer. We've got the ability to pull signals in that are mechanical and then relate the electrical to the mechanical all in the same instrument. So you can do things like efficiency measurements. We're going to take our electrical energy and we're going to look at our mechanical energy. We're going to compare those and see how efficient are we in terms of converting that electrical energy into mechanical energy. So there are lots of great tools in here. We've got things, you know, even if you don't want to use any of the measurements we've got set up, we've got opportunities to open up the scope and look at many different types of measurements that are in there. So this is a fully loaded demonstration scope. You can see there are just a ton of measurements that you can make with it. One of the things that's also super nice about that is a measurement's only one part of the story. We can start pulling in statistics, we can start pulling in histograms, and you can use that information to do quite a lot of things with. You can set up some complex triggering, really nail down to the problem in your system that is something you want to focus on so that you can then debug it, solve it, and get this product out to market.